Hi, welcome to the ShiCoMathLab differential equation problem solving sessions. Today we are going to start to solve a new type of the second order differential equations here. In fact, I think this probably is the easiest one to solve. Okay, so we are dealing with the second order differential equation, but with all the constant in front of it all the number in front of it are the constants here. So now, let me write, write down the the things here. So in general, if I think in your teacher should will tell you. So in general, if this is by prime plus cy equal to 0. So all the number in front of it is a constant here, right? So the one we solve it, so basically we want to solve like the a the r square plus b the r plus c equal to 0. So this is a quadratic form, right? So we know it's going to have two solutions, R1 and R2 here. All right, so in here we have the three situations. The situation number one here, if we solve it, we find out the R1 and the R2, they are what? They are real number. Right now, your solution will be y to the x here will just be the c1 e the r1x plus c2 e the r2x. Okay. All right, so you can put the c1, c2, so it will be your first solution and the second solutions, right? So R2x, then you can combine them with a constant here. All right, so how about the situation number 2 here? If R1 equal to R2, then we say also we say this is the, the repeated root. Right? So this is a repeat root. Then I can combine my general solutions will be Rx is equal to C1 plus C2 x e the Rx here, right? So if R1 equal to R2 equal to R, so it's a repeat root. That's what I can write here. Number 3 is here. Okay, so number 3 is here. If it's a complex root, we notice we have imaginary roots, right? So we have a complex number, we have imaginary roots. So we know the R will be the R can write in the complex numbers, right? So we'll say the R could be R plus or minus beta i's here, right? So the complex roots here is plus minus beta I. So my general solutions here, yx can be written as e to the alpha x. Okay, now I have c1 cosine beta x, all right? Then plus c2 sine beta x. Okay, so hope that we will remember this. All right, so now let's see for this problems here. Okay, so in here I want to tell you a little bit why we just want to solve the AR squared plus BR plus C. Because in this second order differential equation, it did not tell us so it did not tell us any given solution. So we need to guess what type of the solution, possible to be, right? Okay. So for this situation, the way we guess here is yt to the ERT. Okay. So then you will say, okay, so if this is yt, then the first derivative will be the RERT. Then the second derivative will be R squared ERT, right? Then when you plug it back to my differential equation y double prime, so you will have R squared ERT minus 6R ERT, then plus 9 ERT equal to 0. So you can factor the ERT out, right? So you have R squared minus 6R plus 9 equal to 0. That's why I said because the ERT will never be 0. So that's why we need to solve is the R squared minus 6R plus 9 equal to 0. That's why in here I put over here, I said if you have this ones here, basically we want to solve this quadratic forms, right? So AR squared plus BR plus C. The reason why is because the problem did not tell us what is the first solution, so we guess. So we guess the YT equal to the ERT. So it have a certain, because the derivative of ERT have a certain good characteristic. That's why we end up with R squared minus 6R equal to 0. So what is this one? Oh, this one is easy, right? So this will be R minus 3 to the square equal to 0. So I know the R equal to 3. This is the repeat root, right? So this is repeated roots here. So that will be our second situation here, right? So that will be our second situation. So my general solution, I can combine the two solutions here. So will be C1 plus C2 XERT. Okay, so my general solution YT will be equal to the C1, okay, C1 plus C2, C here, right? So C1 plus C2 XERX, all right? So it's C1 plus C2T ERT, right? So what is the RTs here? Okay, so the RTs will be 3s, right? So it will be 3T's here, right? Okay, so now let's continue. All right, so here, while ago okay, so this I made one small mistake here, and is here, my parenthesis should be is in here. So it's C1 plus C2X ERX here. So the same things here. So this one here is C1 plus C2, the ERT, because it's a repeated root R equal to 3. So I have 3 T's here. All right, now I can substitute to my initial value y0 and the y prime. Okay, so let's do y prime first. Y prime t, so I can use the product rules, right? So this is a C1, so this is a 3C1. Okay, so I can do this, right? So I can do the product rule. Product rule is easy. So C2, the E3T, then plus 3, the C1 plus C2T, E3T. Right, so I use the product rule, and so I can do the y prime. Okay, now let me substitute the initial value y0 equal to 1, right? So y0 equal to 1, that means C1 plus C2 times 0 times e to the 3 times 0 equal to 1. So it will give me C1 equal to 1, right? Because this is equal to 0, this item equal to 1. So I got it, C1 equal to 1. Let me highlight it. So we know this is one of that. Now I need to do the C2. So I plug in the y prime 0, y prime 0 is here, is C2 e the 3 times 0 plus 3 the C1 plus C2 times 0 e the 3 times 0. All right, so here this will give me 1. Then C1, this one we calculated from previous is 1. This one would be 0. And the whole thing here is equal to 2. So I have C2 plus 3 equal to 2. So my C2 is equal to the negative 1. Good. All right, so now after that, I finally solve my general solutions here. Will be the yt is equal to C1 plus C2t, right? C1 plus C2t, C2 is negative 1 minus t, RT, the e the 3t. Or you can write it e the 3t minus t e the 3t. That's it. Like I said, this type of the differential equation, to me, I think is the easiest one here to solve because you can find those two solutions, then you can use these two solutions as the base to find any combination of the solutions here. So basically, you can assume the solution is yt equal to ERT. Then it turns out to just be a quadratic form. All right, that's it. I hope you enjoyed with this problems here. Okay, have a good day, and I will talk to you later. Okay, bye bye.